Hello everyone. Alright, so let's do another quick little lecture. This is something called DeMorgan's Law. Alright, now you've been doing problems like this on Albert or just other practice things, and while you can solve it, just going through how to solve it for these, I'm going to show you how to turn this into a more simple equation with something called DeMorgan's Law. So here it goes. Alright. In mathematics, you have something called the distribution property, right? Well, it's basically the same thing when it comes to logic expressions like this one. When you have a not outside of these big parentheses of, I'll zoom in. Never mind, I won't. Alright, so when you have this not outside, it actually distributes out to everything else. So basically what that would mean is it would go out and go to everything in there. Now, you probably understand how that works in math. You multiply them, right? But you might not really understand how to multiply a not with an and. And that's what DeMorgan's Law kind of guides you on. So, for instance, this expression comes out this way instead. We might break it up into, I'm not going to write all that, not, and I'm just going to kind of slowly go through breaking this up. Now, here's the thing. So far, the first part you understand, I just kind of multiplied it, I put it right outside the parentheses for this one. Now, when it comes to the and, I'm going to turn every and into an or. So this and here becomes an or, and then not goes applied to this parentheses, so true and true. I'm going to keep that the same for just a moment. Alright. So then we have that. I'm going to make it multiply out some more. So that way it's going to be not is going to change every part of these parentheses. Now, I could have just done that at the beginning, but maybe it'll help you more to see it written out like this. So this just makes things a lot simpler because now I have these expressions. True becomes false because it's not true. Not or becomes and not false becomes true. So that means that this first expression here is equivalent to false and true. My or stays the same because I've already knotted it. And then lastly, my not multiplies out here, so true becomes false, and becomes or, and true becomes false as well. So then, at this point now, I can solve this a little easier. Putting false and true together, we know evaluates to false. Putting false or false together also evaluates to false. So we have false or false. That's going to go ahead and carry out to a false as well. And while you could work this out here, take this little section here and go true or false. Okay, well that evaluates to true. And this and would evaluate to true and true, which is also true. So this becomes true, and then the not makes it a false. You could have also worked it out like that, but this one might be a little easier using what's called DeMorgan's Law. Anyways, that's it. It's a little short video to go through that. See you next time.